Welcome to this presentation on Splunk development, a high-level process overview. Does it make sense to watch this video? Are you planning on developing apps with Splunk? Would you like more than one person to work on a Splunk app? Do you need a structured process for packaging and deploying apps? Are you planning on deploying Splunk apps on a regular basis? If you answered yes to any of these questions, it probably makes sense to watch this video. In this video, we will demonstrate setting up a local development environment and doing so quickly, changing code and testing locally, committing the change to source code repository like Git, and the automatic packaging, verification, and deployment of a Splunk app to an integration server. So let's get started.
First, let's go to our source control system. I need to make a minor change to a Splunk app, but I don't have it on my computer. I'm going to check it out directly from a Git repository to my local disk. I'll click the icon to copy the URL of this project to my clipboard. Then, using my development tool, I'm going to clone this project onto my local disk. I'm using IntelliJ. You could use Git from the command line if you'd like. Notice the location I'm putting the project on my local is not the Splunk install location. Now that I've checked it out, there's just a few clicks so that I can develop within my IDE. Now you can see my project structure. Notice that the app we're working on is one level down in our project. This is so we can have various project-related files in source control, but not within the Splunk app structure itself. For example, the Jenkins file details the automated process to build and deploy the app. This configuration is stored with the project. Also, a git ignore file that tells Git what files to not save into the repository. This is especially important for Splunk development, as we do not want to store the local folder that Splunk generates within our source control repository. Luckily for me, as a developer that needs to make a quick change to this project, everything is set up for me. At this point, we can see the project on my local drive, but Splunk doesn't know about it yet. When I look at the Splunk apps, I do not see the DTR app that I just checked out. To let Splunk know about my development environment, I need to create a symbolic link to my development folder. To do this, I will create a junction link using the mklink command. I'll open a command prompt as an admin and type mklink/j for junction, the name of the app, in this case DTR, and the path to the app's location, which is on my hard drive, the C development folder with Splunk and projects inside it. Now, when I look back in Windows Explorer, I see the DTR folder. Though it's a link, Splunk treats it the same as any other folder in the apps folder. Before we make any changes, let's make sure the app appears in my local Splunk. I'll go to the Splunk Web UI, go to Server Controls, and restart Splunk. This normally takes a minute or two, but I've sped up the process for this video. Now we'll log in and see the app is loaded. The other app you may have noticed is the Eventgen app. This is an app that looks within other apps for an Eventgen configuration file, then generates data accordingly. Instead of being dependent upon various sources of data, my development environment is self-contained. I can be completely disconnected from key data sources and still do my job. During the remainder of this demonstration, you'll see numbers increasing in the DTR app, otherwise known as the Periscope for Security app. This is data being generated by samples we have configured within the app using Eventgen. As a developer trying to make a quick change, I didn't have to worry about connecting to the data, and that is a huge benefit to me. Now, let's make a quick change. I need to modify a label to say Periscope for Security Dashboard instead of Periscope Security Dashboard. So I open up IntelliJ and navigate to the file that controls that dashboard, the Periscope for Security XML file. Once inside that file, I'll make the edit that I need to make. Next, to verify the change happens on my local Splunk instance, I'll need to restart again. Once again, I've sped up the video a little bit to make this faster. I log back in, go to the Periscope for Security app, and then verify that the change has been made. Here you can see the word for has been added to the label. So my local environment checks out. Let's take a look at the integration server my team uses. Here we see that the title is the old title. Let's go back to IntelliJ and commit the changes that we've made. I'll type in a new commit message, and I'll commit and push to our source control server. This will automatically trigger a package and deployment to our integration server. To see this, let's go back to the web browser and open up Jenkins, our continuous delivery server. Here we can see that a build has started. Let's take a look at the pipeline. We can see that this Jenkins pipeline will first package the app using the Splunk packaging toolkit. Then we'll run a number of inspections using Splunk's app inspect program. This verifies that we have a well-packaged app that is ready to be deployed. Next, the app is deployed to our Splunk server, and that service is restarted remotely. If any errors were to occur in this process, the deployment would be halted. Next, we log back into our integration server and see the change was successfully made.
So what did you learn? Well, a Splunk development process can be simple. You can set up a local development environment quickly and easily. Data generation using Splunk's Eventgen app frees you from needing real data. Jenkins can be used to automate Splunk app delivery by packaging with the Splunk packaging toolkit, checking quality with Splunk's app inspect program, deploying to a Splunk server, and restarting that Splunk server. Thank you for watching this presentation. If you have any questions, feel free to reach out to myself, Jason Jolly, or to Frank Lupo. Thank you.